All right, hey guys, section 2 of the quiz review for 7.6, 7.8. So write an equation in general form for a polynomial function with real coefficients and then it tells you the zeros. So real coefficients are just telling you that by the time you're done with this, you should have no imaginary numbers. So if you have any i's in your answer, you're not correct. You have to go back and change it because it says real coefficients, so no imaginary numbers. So general form means that we need it all multiplied out so that each term is separated by addition or subtraction. So we're going to start out by using factored form and then go to general form from there. So in A, they tell us that we have zeros at x equals 3 and x equals 4i. Now remember, imaginary numbers always come in pairs. One positive and one negative. Those are their conjugates. Always in pairs. So not only does x equal 4i, but you have to know that x also equals negative 4i. Okay, that's an important part. If you miss that, it looks like there's only 2 zeros, when in fact there are 3. So we write our equation, y equals, I'm not going to worry about an a here because they didn't say anything about a vertical scale factor, so we're just going to assume that it's a 1, so I'm not even going to worry about it. I'm just going to do my parentheses, x minus 3, x minus 4i, and x plus 4i. And then we're going to FOIL or use our area model, whatever works for you. I like to get rid of the imaginary numbers first, so I'm going to start out with these two parentheses on the end, and I'm going to leave the x minus 3 alone for now. So y equals x minus 3. I'll FOIL this one. I'll do the next one with an area model, if that's okay with you guys. So from here we go x times x, that's x squared, x times 4i, that's positive 4ix, negative 4i times x, that's negative 4ix, and negative 4i times positive 4i, that's negative 16i squared. So let's continue to simplify what's in those parentheses. So I'm going to again leave the x minus 3 alone. I'm going to combine my like terms, which actually happen to cancel out, which is very nice. There go 2 of my i's. And then on the end over here, remember I squared becomes a negative 1. So this is actually negative 16 times negative 1. So these parentheses on the end, once these cancel, and I do negative 16 times negative 1, which is positive 16, these parentheses just end up being x squared plus 16. So now I have another set of parentheses to FOIL, these two, and then I'm done. So y equals x times x squared, that's x to the third, x times 16, that's 16x, negative 3 times x squared is negative 3x squared, and negative 3 times 16 is a negative 48. So it looks like I'm done, but remember general form is in decreasing order of exponents. So I have my x to the third here, but then my x squared is here and my x to the first is in between, and that's not general form. So let's rewrite it. So x to the third is first, then I'm going to bring this term next, so negative 3x squared, then I'll move my 16x, so positive 16x, and finally the constant at the back. And there is general form of a polynomial function with real coefficients. Notice there's no more i's in the answer, and the zeros are at 3, positive 4i, and of course, since they're always in pairs, negative 4i. So believe it or not, that was the easiest one on the page. The other 3 are a little bit trickier because of the complex numbers, not just imaginary numbers. So let's go through and look at B. So B is the same steps, but we have zeros at x equals negative 2 and x equals 1 plus 3i. So now remember, this is an imaginary number, so this in pairs. So we're also going to have x equals 1 minus 3i. So again, we have 3 zeros, not just 2. The other one is just hidden because it's the conjugate of the other imaginary number. Okay, you have to remember that. So here's why it gets a little bit tricky, because when we're setting up our equations, here's what it looks like. Y equals, again I'm going to assume a is 1, so I'm not even going to worry about it, and the x plus 2 is normal. But then we have x minus, and we have 1 plus 3i. So that becomes a minus 1 and a minus 3i, because they were both positive and I'm subtracting. Then for my next parenthesis, I have x minus. Again, I'm subtracting, so my minus 1 stays minus 1, but my minus a negative 3 becomes a positive 3i. So here's what this looks like. And if you notice, I'm going to go right to my parentheses with the imaginary numbers, but I don't just have a binomial and a binomial. I have 2 trinomials now that I have to factor. And that gets a little bit trickier. So what I'm going to do is I'm going to use an area model because it's a little bit easier to keep track of all my terms when I have so many things going on. So again, I'm going to leave the x plus 2 alone because that's a nice, neat little function. The other two are looking like a mess right now, especially with the imaginary numbers. So off to the side, which I don't have much room on a side, I'm going to do my area model. So a 3 by 3. So I have x, negative 1, negative 3i, and an x, a negative 1, and a positive 3i. So let's fill in our square here. So x times x is x squared. X times negative 1 is negative 1x. X times negative 3i is negative 3ix. Negative 1 times x is negative 1x. Negative 1 times negative 1 is a positive 1. Negative 1 times negative 3i is a positive 3i. Down on the bottom, 3i times x is 3ix. 3i times negative 1 is negative 3i. And 3i times negative 3i is a negative 9i squared. So I'm going to go through this area model and pull out and combine like terms. So I have an x squared in the first box. There's no other squared, so I'm keeping x squared. Negative 1x here. I have a negative 3ix here, a negative 1x here, and a positive 3ix here. Well, my positive 3ix and my negative 3ix, those cancel, leaving me with just negative 1x and negative 1x, which is negative 2x. Okay, so continuing, I see this positive 3i and negative 3i. That's nice. They go away. And then I have the plus 1 here and minus 9i squared. Now normally those don't look like terms, but remember I squared is equal to a negative 1. So this is really negative 9 times negative 1, which is a positive 9. So now I have like terms. 9 and 1 make 10. So I have a positive 10. Okay, so I know that wasn't great fun, but you see how an area model makes it a little bit easier to go through and look for your like terms, cross out what you don't need, and simplify, and it keeps everything in nice, neat order. You can try to FOIL it, but I just find this way to be a little bit simpler. Okay, so now I have a binomial times a trinomial, and if you would like to FOIL this, you can go right ahead, or you can draw yourself another area model. The area model for this would be a 2 by 3. I'll continue with an area model for this one, and then maybe we'll FOIL the next. Okay, so while we're working with area models, I'll continue with this. So I have a 2 by 3 now, so 2 down the side, x and 2. And x squared negative 2x and a positive 10 here. And again, go through and fill in all your boxes. X times x squared is x to the third. X times negative 2x is negative 2x squared. 10 times x is 10x. Oops, excuse me. Okay, sorry about that. So multiply x times 10 for 10x. 2 times x squared is 2x squared. 2 times negative 2x is negative 4x. And 2 times 10 is 20. So we'll go through and combine like terms. So nothing like x cubed, so I keep x cubed. Negative 2x squared and 2x squared. These guys cancel. 10x and negative 4x. That gives me 6x. And nothing to combine with 20, so plus 20. So here is the general form of a polynomial function with real coefficients. Again, notice there's no imaginary numbers, and zeros at negative 2 and 1 plus 3i. Okay, on to example C. So zeros at x equals 2 minus 5i and x equals negative 3. So remember, 2 minus 5i also has a 0 at 2 plus 5i. Okay, so let's do the equation. X minus 2 minus negative 5i is plus 5i times x minus 2 minus 5i. Okay, times x plus 3. Okay, so again, first two I'm going to do right here, trinomials. I'm going to continue to draw my area model for this one, for those trinomials. So x, negative 2, positive 5i, x, negative 2, negative 5i. So let's go through and fill that in. X squared, negative 2x, 5ix, negative 2x, positive 4, negative 10i, negative 5ix, positive 10i, and negative 25i squared. Sorry if that one is a little hard for you to see. Okay, so x squared, nothing like it, so y equals x squared. The 5ix and the negative 5ix cancel. The negative 10i and positive 10i cancel. Negative 2x and negative 2x make negative 4x. Okay, and then I have positive 4 and the negative 25i squared. So remember, I'm just going to do a little side note, negative 25i squared is negative 25 times negative 1, which is positive 25. So I have positive 25 plus 4 is positive 29. And I still have this x plus 3 on the end to multiply by, so times x plus 3. Okay, so now let me get this out of the way. I'll erase this, pause or rewind if you need to. And now we'll FOIL for those of you that like to FOIL. So we FOIL. So we have, how about pink? X squared times x, x to the third. X squared times 3, 3x squared. Negative 4x times x, negative 4x squared. Negative 4x times 3, negative 12x. 29 times x is 29x, and 29 times 3 is 87. Combining our like terms, finish up, we have x to the third, doesn't have anything else like it. 3x squared and negative 4x squared, that's negative 1x squared. Those guys are done. negative 12x and positive 29x. That is a positive 17x, and those guys are done. And then the plus 87 on the end. And there is general form of section 2, letter C. Okay, on to D, much of the same thing. If you want to pause and try it on your own and then see if you get the same answer, we can go with that. So D, zeros at x equals 7, whoops, and x equals 1 plus 8i. So the other 0 is at 1 minus 8i. Let's write out the equation. X minus 7, x minus 1 minus 8i, and x minus 1 plus 8i. Okay, so as I've done in the past 3 examples, I'm going to start with my imaginary numbers. I'm going to draw the area model for the 3 by 3. So x, negative 1, negative 8i, x, negative 1, positive 8i. Multiply x squared, negative 1x, negative 8ix, negative 1x, positive 1, positive 8i, positive 8ix, negative 8i, and negative 64i squared. So you notice the pattern here, I hope, at this point, that our ix's cancel, the negative 8ix and positive 8ix, and the i's also cancel, the positive 8i and the negative 8i. Then the I squared changes to negative 1, which makes my number in here that was negative, makes that positive. So I end up adding that to this number here, and that's how I get my simplified version. So y equals x minus 7 times x squared. Combine these two guys for a negative 2x. Combine positive 1 with positive 64 for a positive 65. Okay, so from here, if you want to draw another area model, if you want to FOIL, it's up to you. I'm going to continue. I'm going to FOIL. So I have x times x squared is x to the third. X times 2x is negative 2x squared. X times 65 is 65x. Negative 7 times x squared is negative 7x squared. Negative 7 times negative 2x is positive 14x. And I was trying to do this without having to erase, but that's not going to work. So I'm going to erase. So then I have negative 7 times positive 65, and that's negative 455. Going through to combine our like terms. Nothing like x to the third, so that stays. Negative 2x squared and negative 7x squared is negative 9x squared. They're done. 65x and 14x makes 79x. They're done. And then nothing like the constant, so we put that on the end. And there we have section 2, part D, an equation in general form with real coefficients.